So I am recording this lecture. All right. Our next topic is about potential energy and energy conservation. So this is the continuation of our topic previously, which is about work and energy, right? So in potential energy, we will be dealing with gravitational potential energy as well as the elastic potential energy for these cores. Okay, when we say potential energy, this is the energy associated with position, like for example, the gravitational, elastic, or electric. Okay, so when we say potential energy, this is the potential or possibility of work to be done, where we will be using capital U. Can you see my cursor? Makita niyo akong cursor?
Yes,
Yes,
ma'am.
ma'am.
Okay. So, klaro rin po ako ang kuan on. Alright? So, we will be using capital U for potential energy, and the subscript G here is for gravitational. Okay, so again, because this is due to gravity, so we have here the mg, which is the weight, and this is also associated with position y, that is along the y-axis. Let me admit first, everyone. Okay, so the gravitational potential energy U or UG is equivalent to mgy. Again, y here is our position along the y-axis. Okay, now whether the object is lifted upwards or moved downwards or upwards, we have the same work done by gravity, which is the negative of delta U. Take note, if you can recall previously, the work energy theorem in terms of kinetic energy is, sa ganitong work energy theorem, in terms of kinetic, we have change in kinetic energy, which is final minus initial, by which here, work done by gravity is initial minus final gravitational potential energy. So this is the work done by gravity. Okay. So the potential energy for an elastic object, such as the spring or rubber band, um, again, is what we call the elastic potential energy. So kagaina, due to gravity, that is gravitational potential energy. But due to elastic objects such as springs or rubber bands, we have elastic potential energy. Okay. Now, the elastic force required to stretch or compress a spring at distance x is given by this force F, which is equivalent to kx. K here is the spring constant with a unit in terms of Newton per meter. So this is the unit for the spring constant K. Okay. Now we have the specific unit for, specific um, constant value for a specific springs. Naman tay mga springs nga stiff, naapoy mga humok pod no nga mga springs. So they have different values for the spring constant. Okay. Now, the potential energy or the elastic potential energy for springs is expressed as 1 half kx squared, given here. That is 1 half kx squared. And the work energy theorem for elastic potential energy, so that is the same with the work done by gravity, which is initial minus final. Again, we have initial minus final elastic potential energy. So this is now the work done by the elastic bodies such as the spring. Okay. Now, um, dili na lang siguro ta. Okay, so we will have also the total energy of the system. The total energy of the system, which is called the mechanical energy. That is the sum of kinetic and potential. So E equivalent to K plus U. We will be using capital E for mechanical energy. Now, the principle of conservation of mechanical energy uh, states that the mechanical energy of the system doesn't change. That means the total mechanical energy at the initial position will be equivalent to the total mechanical energy at the final position. So here we have the principle of conservation of mechanical energy, wherein on the left side of our equation, can you see my cursor, mga langga?
Yes,
Yes,
ma'am.
ma'am.
Okay, thank you. So wherein on the left side of our equation, we have all the initial values. These are the initial values. And on the right side of our equation, we have the final values of kinetic and potential energies. As you can see, potential energy is also the sum of gravitational and elastic. Okay, gravitational and elastic potential energies. Now, take note also that this is true only when, okay, the principle of conservation of energy is true only when only gravity does work on the system, or when only the elastic force does work, or both elastic force and gravity do work. But if there are forces other than the gravity and the elastic force that do or does work, then the mechanical energy is not anymore conserved. We cannot anymore use this formula, but we will be using this one. Okay, so this will now be our general work energy theorem. We have initial kinetic energy plus initial gravitational plus initial elastic. We will be adding on the left side of the equation the work done by that other force. Okay, so unsa man ang mga um, situations wherein there are work done by other forces. So say for example, friction. If there's a presence of friction, so there will be work done by the friction other than the gravity or other than the elastic force. In that case, so mechanical energy is not anymore conserved. We cannot anymore use this formula, but we will be using the general work energy theorem. Okay. Now let's have an example. Wala pa di ay. Joke ra to. Okay. So before we will have an example, let us first look at the conservative forces. So again, the two conservative forces are the gravitational force and the elastic force. So these conservative forces offer a two-way conversion between the kinetic and potential energies. Take note that it doesn't depend on the path. Okay? It doesn't depend on the path. It only depends on the initial and final positions. Like for example, okay, here we have the work done by the gravitational force. If only gravity does work on the body on this person who is jogging, na atay initial position at this point, we also have the final position at this point. Okay. Now, as you can see here, we have three. Ay, sa akin nag-admit pa ta. Okay. As you can see here, we have three paths. Okay. One path, kaning green path. Can you see it? Makita ba? Okay. We have one path. Again, this is the green path. Second path, kaning blue. Misaka siya sa hill. And the third path, kaning red. Naog, nag-curve-curve, hangtod miabot siya sa final position. Again, so for this person, we have the same initial position, or for these three paths, rather, we have the same initial position. We also have the same final position. Now, take note, if only gravity does work, take note, gravitational force offer a two-way conversion between the kinetic and potential energies. So that means, if only gravity does work, it doesn't matter on the path it takes, magtan-aw ra ta sa iyahang initial o final nga points. Okay. So that means, if only gravity does work on any paths taken by this same person, then the total mechanical energy at the initial position is just the same. or equivalent to the total mechanical energy at the final position. It doesn't matter kung unsa ang path ang iyahang gitake. Bahalag magliko-liko pa na siya. Basta magtanaw ra ta sa initial, first position, and final, or the second position. So the same goes here. There is a bola. Now, take note that if we will consider this point here at y equivalent to 0, then our gravitational potential energy at the ground will be equivalent to what? Ang ato ang y dire at this level is 0. Then your gravitational potential energy, take note, your gravitational potential energy, let me write it here, is mgy. If we will set this ground level to be our reference level at y equivalent to 0, what will be our gravitational potential energy at the ground level? Hello? Hello? Wala, nadunggan ko, wala. Wala na. Wala ko nadunggan.
Zero.
Okay, so gravitational potential energy at this point will be 0. Again, because mgy equals 0. Maklaro ba ninyo kung sinulatan? Okay, ako lang dako on niya. Now, in that case, if this object here is dropped from rest, if it is dropped from rest, therefore your initial velocity is dropped from rest at this point. So at this point, your initial velocity is what?
Zero.
Okay, that will be 0. In that case, if your initial velocity is 0, your kinetic energy at that point will also be okay,
Zero.
your kinetic energy at that point will also be 0. Okay,
Zero.
your kinetic energy. But take note, since this is the highest point of the ball, kay imo man siyang dropped from rest at that point. So this is the maximum y position that this ball can have. In that case, since mo ning pinakataas niya nga y position, then we have the maximum value of the potential energy. Okay? We have the maximum value of the potential energy at this level. But take note, since ang kinetic energy at this level, since it is released from rest, kinetic energy is 0. So, minimum po imo ang value sa imuhang kinetic energy. Now, kung magkaanam-anam na siya og kanaog, like for example, pag abot dinhi, unsay mahitabo sa imuhang potential energy?
Ugamay,
Ugamay
ma'am.
man imuhang y, no? So, unsay mahitabo sa imong potential energy? Yes, Vince?
Mugamay, ma'am.
Mugamay po imong potential energy. Pero unsay mahitabo sa imong kinetic energy pag abot dire? Di ba gikan man
Magka-increase.
kag 0, imong kinetic energy, yes Vince?
Magka-increase.
Mo increase pud imong kinetic energy. Okay, nakuhaan imong potential pero imong kinetic mo increase. So take note that the sum, since only gravity does work here, right? Only gravity does work here. Kay gi-release man na nimo from rest. So ang imong free body diagram is only the weight. And we also have the displacement that is downwards. So the weight is doing work on the ball as it falls, right? And only gravity does work. Since only gravity does work, take note, the the mechanical energy, which is the sum of kinetic and potential, is conserved. In other words, ang sum of kinetic and potential from the initial position is equivalent to the sum of kinetic and potential at any point here sa imuhang second position. So, pag abot niya diri ni gamay imuhang potential energy kay ni gamay man imong y. Pero mudako imuhang kinetic energy kay mudako mo ka-increase man pud ang iyang speed as it goes down. Right? Okay. In that case, nakuhaan imuhang potential energy, nadugangan imong kinetic, therefore, ang potential energy nga nawala, na-convert into what?
Ma'am.
Into kinetic energy. But take note, the sum of kinetic and potential at any point is just the same. Okay? Pag abot dire just before, ayaw po nang dire na gid sa ground, no, kay mo stop naman gid siya just before it reach the ground. Just before it reach the ground, ang imuhang potential energy unsay mahitabo? It will approach to, what will happen to your potential energy when it reached the ground?
Zero.
Okay. So ang imong potential energy will approach to zero before, just before. Okay, just before it reach the ground, your potential energy approaches to zero. Therefore, imong potential energy is minimum na pud iyang value. Ang imong kinetic energy na pud nimo ang mooy maximum nga value. So, in other words also, ang tanan nga potential energy nimo diri sa first point na convert na into kinetic energy tanan sa imuhang second point. Again, the sum of kinetic plus potential at the first point is just the same with the sum of kinetic and potential at the second point. In that case, if only gravity does work, mechanical energy is conserved. So the same goes here sa ato ang second na figure by which bahalag unsa pay iyahang giagian, magtuyok-tuyok, munaog, musaka, whatever, or straight ba na ang iyahang path. Take note, we will only take a look at the first position and the second position. If only gravity does work, again, if only gravity does work, then mechanical energy is conserved. Total mechanical energy at the initial position is just the same with the total mechanical energy at the final position. So that's for the gravitational force and the elastic force that offers two-way conversion between kinetic and potential energies. Okay? So again, a frictional force is one of the forces that causes um, the mechanical energy to not be conserved. Okay, dili conserved ang mechanical energy kung naay presence of other forces than gravitational and elastic that does work. Okay. Now we can have our example. Right. Now here you throw a 0.145 kilogram baseball straight up in the air, giving it an initial upward velocity of magnitude 20 meter per second. Now take note in this case, imo man na siyang itsa pasaka. Ang atong i-consider nga point is when it already leaves your hand. So ang bola na-release na sa imuhang kamot. When the ball is released from your hand, unsa naman lang ang imuhang diagram karon, free body diagram sa bola. When the ball is released from your hand, nawala ng exertion of force sa imuhang kamot. Gi-release nimo siya, it now has an initial speed of 20 meter per second. What is the force acting on the ball now? Hello, Jed? What is now the force acting on the ball as you release it with a speed of 20 meter per second? Gi-release man nimo siya, it then falls freely, right? It moves up, and then pag abot sa highest point, it will eventually stop for a while and then change its direction from upward to downwards. Again, it falls freely under the influence of gravity. So what is the force acting on the ball in that case after you release it with a speed of 20 meter per second? Jed? Di man matingog si Jed. Renato? Hello? Can you still hear me? I-open ang mic. Di ko makadungog. Renato?
Um,
Si Jade. Si Jade. Hala, duha man ni. Na ay Jed Goles. Na po Jade Kurt. Sige, Jade. Matingog na si Jade. Sige, Jade. Unsa man ang force nga, let's say for example,
siguro,
what will be the free body diagram of this ball? If we will draw the free body diagram, what are the forces acting on it?
gravity.
Okay, the force due to gravity that is downwards, right? Okay, ato i-draw kung maklaro. That's the weight downwards. What else? Naapa bay lain? Gi-release naman mo sa imong kamot. Naapa bay lain? Aside from the weight? Hello? Napabay Jade?
Wala naman siguro
Wala na,
ako
no?
usual.
Okay. So, this is under the influence of gravity alone. So, girelease. Take note, ang kanang kamot diha, gipakita lang na nga imuhang itsa na sa pasaka. Pero, ang atong i-consider karon katong wala na gyud ang imuhang kamot, nag-touch sa bola where it has a speed already with a 20 meter per second nga speed. So we will consider that point to be our y1 equivalent to 0, your initial position. Okay? We are asked here to find how high it goes. So highest point. At the highest point, your velocity is sa exam, dagay na sayo pa ani. At the highest point, your velocity is
Zero.
zero. Okay.
Zero.
So, ang atong himuon nga second position or final position will be the this y2 or final position at point where it reached the highest point. Okay? So from point 1 to point 2, take note only weight is doing work on the body. Kaya wala man kay laing force here. We ignore air resistance or friction. We ignore air resistance or friction. So only weight is doing work. If only weight is doing work, okay, duhara man gyud when we try to answer problems, duhara man gyud ang ato ang gamiton nga formula. Akong ibalik no. Duhara gyud mo'y nakanindot diri. Take note, this is free fall. We can also answer this problem using katong free falling bodies, katong upat ka kinematic equations. Even sa inyong exam, no, nigawas man ni. Okay? So, but in this case, we will be using or we will be answering the same problem or somehow the same problem about free fall, pero we will be using the concept of energy conservation. Okay? Now take note, if only gravity does work, duha ra man atong pilian ani. Kanira man, okay, for the principle of conservation of mechanical energy kung conserved, and kaning naa sa ubos kung dili conserved. Alright? So here, in this case, in answering this problem, we have the initial position o final position. From the first to second point, ang akong pangutana, is mechanical energy conserved or not? Is mechanical energy conserved or not? Yes, Lindy? Sige, Renato. No, naglibog na hinuon. Sige, tubag daw. Is mechanical energy conserved or not?
Conserve, ma'am.
Conserved ka? Ngano gani, Renato?
From potential is na-convert into kinetics siya, ma'am.
Okay. Ang
Kay
atong
gikan sa
lantawon, yes, very good. Ang atong pong lantawon, no, if only gravity does work, okay, if only gravity does work, then mechanical energy is conserved. So, ang atong nakita dire, ang weight raman ang nagbuhat og work sa iya ha, from the first point to the second point. In that case, mechanical energy is conserved and we can use katong first equation. Hopefully maklaro mo ni ako ang concern kagaina kay dili man maklaro ako ang sinulatan. Klaro ra? Okay. So from the principle of conservation of energy, we have initial kinetic energy plus mga initial sa left side, final sa right side. Initial kinetic energy plus initial gravitational potential energy plus initial elastic potential energy. On the right side of the equation, we have the final values. Final kinetic plus final gravitational plus final elastic. Now, naabatay elastic potential energy from the first point to the second point. Hello, do we have elastic potential energy from the first point to the second point?
Wala, ma'am.
Wala kay ngano, wala man tay springs dinhi right?
Wala
So we
yes,
can
ma'am.
cancel out. Okay, so we can cancel out the elastic potential energies. Unsa pa may ma-cancel out nato diha? Okay, do we have
ang kuan,
kinetic
ma'am.
initial?
Wala, ma'am.
Ang
Ay
initial,
be?
ang initial,
Wala lagi.
initial. Okay, tan-aw na to. Sa initial position, naatay initial velocity nga 20 meter per second. So, do we have kinetic? Initial na ano? Okay.
Naa, ma'am.
Na. Now, next sa gravitational potential energy, ang gravitational is mgy. So, at the initial position, unsa man atong y initial? Y initial is
Zero.
0. So, do we have
Di,
initial gravitational potential energy?
wala.
Okay,
Zero,
so we
ma'am.
can cancel this out also. Okay, ang nakanindot dire kay pwede gud nato siya himuon nga reference level ang atong initial position so that yung initial position nato himuon natong 0, ma-cancel out na nato ang isa ka term. Mas dali siya kay daghan tag ma-cancel out. Okay? Now, for the final kinetic energy, kinetic energy is 1/2 mv squared. At the final position, do we have final velocity? At the final position, do we
Wala,
have
ma'am.
final velocity? Wala. Okay, at the highest point man no.
Zero, ma'am.
So, imong kinetic energy will
Ma'am.
be 0 at the
Zero.
final position. What about the gravitational potential energy at the final position? Nabatay final position? Nabatay value sa final
Yes, ma'am.
position? Yes. Okay, and ang
Zero,
kanang
ma'am.
y diha kani ang ato ang gi pangita. Right? So, how high it goes, ignoring the air resistance. So, makita na to siya dire sa UGF final. So, what's left here is, we only have the initial kinetic energy. This is equal to final gravitational potential energy. Okay? So, let us substitute the values we have here. Initial kinetic energy, 1/2 m v initial squared. On the other side, we have M, G, Y, final. Again, unsa tong target diri Our
Ang
target here is,
ma-isolate ang wifi.
yes, so ang Y
Ang wifi
final.
naman.
So all we have to do is to divide
Divide
both
both sides by
sides
MG.
by, very good, MG.
MG.
MG. Okay, so we can cancel this M, we can cancel the G. We can also cancel the M here, right? Okay, common man pud si M. Numerator and denominator. So what's left here? We have, okay,
1/2
sultan
velocity
tagere.
initial squared over
Okay, sultan
gravity.
tagere, no? So the final position will be 1/2 tapos initial velocity squared all over g. Okay? So let us substitute the values. Substituting the values, we will have 1/2. Hopefully makaklaro pa mo. Initial velocity is, pila ga itong initial? We have,
20.
okay, that's
20.
20 meter per second quantity squared. Hindi na makita. Okay, so we have 20 meter per second squared. Ayun. All over G, which is 9.8 meter per second squared. With this value, our final position is equivalent to what?
20.4
Depende
meters.
ako, ma'am.
20.4.
Okay, very good.
20.4.
So, 20 squared divide 9.8 divide 2. So, we have 20.4. Yun. So, we have 20.4. Unsa may unit, ani? This is in
Meters.
meters.
Meters,
20.4
meters lang.
meters. This is now the highest point reached by an object released with a speed of initial velocity or initial speed of 20 meter per second. Okay. So, kana ra gyud ay nga gihatag da ay no? Speed ra gyud atong kinahanglan. Initial speed. Makuha na nato. Okay. Compared to, take note, compared to sa katong free falling free fall nga concept, katong we will be using the four kinematic equations. Can you remember? Kato atong gigamit sa exam. Compared adto
Yes,
og
ma'am.
ani. May mas dali.
Kini, ma'am. Masayon na mi
Kanino?
kay...
Isa ra pagyud ka equation
Yes,
ang
ma'am.
ato ang gamiton. Tapos daghan pagitag ma-cancel out kay daghan tay initial velocity, final velocity is 0. initial velocity, initial position rather, initial position nato atong himuon og 0 para mas dali siya ma-cancel out. Okay, and we can omit more terms. Okay. So let's have another example. All right. So here we have a spring, no? A block connected to the spring. So the block here with mass M or mass 0.2 kilogram sits on a frictionless. Okay, take note, frictionless ang ato ang surface. It is connected to a spring with a spring constant of 5 Newton per meter. You then pull the block. So imuha siyang gibira. Okay, so you pull the block with a force on that direction, stretching it a distance of 0.1 meter. You then release. So, gikan sa pag-stretch, pag-abot niya dire, when you stretch it at this distance, you then release it with no initial velocity. So, if it has no initial velocity at this point, okay. So, the speed here is 0. What will happen to your block when you release it from rest at this point?
Mo kan ma'am kanang mo move.
Okay. So, mubalik siya padulong sa iyang equilibrium position. So, here take note at x equivalent to 0, this is neither, the spring is neither stretched nor compressed. At this point, wala siya gihilabtan. Okay? At this point, wala pa na siya gihilabtan. So, mubalik yun na siya sa iyang original position again or at the equilibrium position. So, pag-release nimo sa block nimo din ha, mubalik na siya, move na siya on this direction directing to the left. Alright? Where, kung asa yung x equivalent to 0, diha siya padulong. Okay? In this case, we have the force, okay, exerted on the block, and then release it from rests with no initial velocity v equivalent to 0 at this point. Okay. The block begins to move back. The block begins to move back towards its equilibrium position kung asa imong x equivalent to 0. Ang pangutana karon, what will be its velocity when it reached 0.08 meters? So pag-abot dinhi. Gikan dinhi, so this will be your initial position or initial speed at that point. Himuon nato ning position 1. Okay? So this is your initial position, position 1. And this will be your final position, position 2. Okay. So your initial position at x equivalent to 0.1 meter. Your final position at your x equivalent to 0.08. Again, 0.08. Pag abot niya dinhi unsa naman ang iyahang velocity? Take note, we are asked about velocity. So you have to include magnitude and direction in this case. But how do we find that one? So gipangita is the final velocity at this point. Again, at your x equivalent to 0.08 meter. Okay, so how do we find that one? In this case, take note, as you release it, unsa man ang force nga nagbuhat og work na lang karon in that case, gikan sa imong pag-stretch. Nagbuhat ba og
Ang
force o ang
elastic
nagbuhat ba og work ang imuhang hand karon? Again, girelease naman
wala na
siya.
ma'am.
Wala na
Kay
no.
Grace mo.
So gitanggal na nimo ang imuhang
Yes
kamot,
ma'am.
wala na ning force exerted by your hand. But take note kay mubalik man na siya sa equilibrium position, naa pa ng force exerted by the spring. Force exerted by the spring on this direction. Okay, so the force exerted by the spring is directed leftwards. It will also move leftwards kay mobalik man siya padulong dinhi. Okay, so therefore, the spring is doing work or not? Nagbuhat ba og work ang spring o wala?
Buhat, ma'am.
Okay, so the spring is doing work on the block. Take note, F spring is directing leftwards. The displacement is also leftwards. Okay, if
Sa
we will
negative.
recall work done, work is F D cosine theta, where theta is the angle between force and the displacement. So therefore here, F spring is doing work on the block. Now aside from the spring, napabatay friction dire?
Wala, ma'am, kay
Wala.
frictionless
Okay.
man.
So here we consider a frictionless horizontal floor. So kung naay friction, so of course ang friction will also do work on the block, right? But since we don't have a friction here, so only the spring is doing work on the block. Now, from your initial position nga gi-consider from x equals 0.1 to your final position nga gi-consider x equals 0.8. Again, from your initial to your final position, is the mechanical energy conserved or not?
Yes,
Conserved bang
ma'am.
energy or
Na-conserve, ma'am.
dili?
Na-conserve, ma'am.
Conserved kay?
Isa naman ka force na nag-acting, which is ang
Okay.
force sa katong spring, ma'am.
Okay. Now, take note ato ang dumdumon, if only gravity does work, katong pareha gain no, if only gravity does work, or if only the elastic force does work, such as here in this case, then mechanical energy is conserved. If forces other than the elastic force, for example, na ay friction diha, dili na conserve ang atong energy. In that case, ang katong general nga equation na ato ang gamiton. Okay? Again, in this case, mechanical energy is conserved, so we can use the equation. We have K initial plus U grav initial plus elastic nga initial. This is equal to final kinetic energy plus gravitational final potential energy plus elastic potential energy nga final. Okay. Now, we will again cancel out. The next step is to cancel out the terms nga pwede nato ma-cancel out katong ma-zero. Let's try to check ang initial kinetic energy. Do we have initial kinetic energy? Hello? Do we have initial kinetic energy?
Wala, ma'am. Zero.
Okay. Kinetic
Kaya
energy
gikuan
is
naman ka ng gikan
zero.
lang sa kamot.
You have released it from
Wala, ma'am.
rest.
Zero.
Okay. Initial speed or initial velocity is zero because you release it from rest. So, imong kinetic energy nga initial will be zero. Now, ang atong gravitational potential energy, take note, ang imuhang y position at the first point is the same sa imuhang y position at the second point. And if we will let this level here, if we will let this level here at, asa mo kong sulat, y equivalent to 0. In that case, sa imong initial position o sa final position, your y will still be 0. So your gravitational potential energy nga initial will be 0.
Zero.
Imuhang gravitational potential energy nga final will
Ito,
also
ma'am.
be 0. Okay. Now let's check.
Zero.
Do we have the initial elastic potential energy? 1 half kx squared. 1 half
Ah,
kx
ma'am.
squared. Naa. Okay, because we have initial x, which is 0.1. Ang imuhang final kinetic energy, atong gipangita ang imuhang final velocity, no? So, naagid ni
Yes,
nga
ma'am.
value.
Naagyapan.
And your elastic potential energy final, at the final position, you have x equivalent to positive 0.08. So, you also have this value. Okay. Now, let's try to substitute its expressions. For elastic potential energy, we have 1 half m v, 1 half kx squared, sorry. 1 half 1 half k, and then x initial squared. This is equal to, the kinetic energy is 1 half m v final squared. Okay. Next, we have plus, kanina lang dayon, which is 1 half, uh, elastic man so 1 half k x squared. 1 half k x final squared. Okay. Again, our target here is to find the final velocity, kani VF. So we will have, okay, so we will transpose this final elastic potential energy on the
Dalhin.
other side, and we will get 1 half kx initial squared, this one. Pagbalhin dayon ani, ma-negative 1 half kx final squared. Okay. So what's left on the right side of the equation is just 1 half m v final squared. Alright. Dili na maigo sa ito ang
Pwede
kuha.
mata ma-divide mo.
Yes. Now take note also that we have a um, common value, no, sa ato ang every term, which is 1 half. So we can divide both, or no, yeah, we can multiply both sides by 2. We can multiply both sides by 2. Again, multiply here with 2. And we can cancel out the 1 half in each term. Okay? So we were left with, saka na ko ha. Kaya di na naman maigo sa atong board. Here, on the first term, 2 times 1 half. Wala na ang 1 half, no? Kx squared na lang. We have kx initial squared. Next, second term, we have minus kx final squared. This is equal to, kanina lang po, m v final squared. Again, what is our target here?
Ang velocity lang ma'am
Okay.
so
So we are
divide both
asked
sides na
to
pod by m.
find, yes, the velocity. So we have to divide first both sides by mass. Divide this by mass. So we can cancel this out. We're left with, on the right side of the equation, ato ibalhin diri ha, we have v final. This is squared. Okay? Equivalent to this whole term here, we have, again, let me rewrite, kx initial squared minus kx final squared all over the mass m. Now take note, since this is squared, ato nang
By
atong
square root.
ikuhaon ang square root both sides. Okay, ako na lang ng irison. And we will have plus minus. Okay, take note, i-appeal gihapon si plus minus, taking the square root. Okay. Now with this value, with this expression, let us substitute the values. Maybe we can substitute it here. So this is plus minus the square root of what? B? Maklaro pa ba? Yeah. Okay, our K is, pila atong K? 5 Newton per meter. 5 Newton per meter. Our X initial here, kani, mo na itong initial
1.
position, 0.1. That's positive 0.1 meter. Do not forget to square. Next, minus. Sakto ba? Wala man na sa no? Minus man na. Ang atong K again, that's 5 Newton per meter times Atong final position x, ang final position diri, that's positive 0.08 meter. 0.08 meter quantity squared. Klaro pa. Okay. All over the mass. Na may mass no? 0.2. All over the mass, which is 0.2 kilogram. Okay. What will be our velocity here?
0.3, ma'am.
0.3. Okay, so that's plus minus 0.3. Tulo man ka significant figures, no? 0.3
Meters per second.
meter per
Meters per second.
second. Okay. So, naaman tayo duha ka possible values. That's positive 0.3 or negative 0.3. Now, asa man diha sa duha? Balik ta sa atong diagram.
Negative,
Asa
ma'am,
man ang
kay
direksyon?
Positive, ma'am.
Okay,
Positive.
negative kay
Negative
Blasil.
ang
Asa to Blasil?
Negative.
alas mo.
Negative, ma'am.
Okay, negative kay
Negative.
padulong man siya directing to the negative direction or to the left. So ang atong ihatag nga final answer is ang negative value. Negative 0.3
Negative
meter per
3
second.
meter per second.
Okay. So that's it. Alright, so we will have last example. Again, in this concept, no, in this problem, we use the principle of conservation of energy. Nga no ganito? Because only the
Isa man nga para nagkuan ma'am force, nag-acting,
okay,
which is ang katong force sa elastic force,
elastic
ma'am.
force or the spring. Only the spring or elastic force does work. Katong kagaina ang previous example, work mechanical energy is also conserved because only
Gravity
gravity
raman na sa
does
wall,
work.
ma'am.
Okay. Now, what will happen to this next problem? Itong lantawon. Ayan. Okay. Now, suppose that the block is initially at rest. The block is initially at rest at x equals 0. Mag-drawing siguro tano. Gamay na ba kayo itong board? Sige lang. So, if this is the spring, okay, nadiri ang block. Again, supposedly, at this point, x equivalent to 0, the block is initially at rest. Okay? So, himo na to ning first point or initial point, no? Initial velocity is 0. Now, hindi na noon kita. You, okay, you then apply a constant force. So, nag-exert ka og force. That's the force exerted by your hand on this direction. Okay? So, there's a force exerted by your hand on the positive x direction with a magnitude of 0.610 Newton to the block. Okay. So, kay nag-exert man ka og force, of course, unsay may mahitabo sa spring. So, ma-stretch na ang ato ang spring. Right? As you are exerting a force on that direction. Okay, that's the force exerted by your hand. Now, what will be the block's velocity when it has moved 0.1 meter? What will be its velocity when it has moved 0.1 meter? So, ang atong initial position is at x equivalent to 0. This is your initial. Ang atong final position is at this point. So, let's say this is x final where, okay, maklaro, where your x is equivalent to 0.1 meter. When your x becomes 0.1 meter, what will be the velocity? So, final velocity na po ang gipangayo. Okay. Before we will answer the problem, we have to identify first, gikan sa imong initial position, hangtod sa imong final position nga imong gi-consider. Is mechanical energy conserved or not?
Lahat
Conserved
ata
ba or
ma'am kay
dili?
na may laing force
Ah, sige.
nag-exert.
Okay.
Which,
Naasi
dili ma'am.
naasi Elmarie. Akong patubag si Elmarie. Elmarie Zay. Okay. Nganong dili man conserve ang ato
Hi,
ang
ma'am.
energy gikan sa first to final position? Elmarie. Yes, Zay.
Hindi ka ma'am?
Okay, gikan sa imong initial position hangtod sa imong final position, akong pangutana, conserve ba ang mechanical energy? Duha ra man to ka klase no, ang possible forces nga mag-exert lang so that our energy will be conserved. Dapat ang gravity lang or ang weight ang magbuhat og work. Ikaduha, dapat ang spring lang or elastic force ang magbuhat og work. Kung kanira duha ang magbuhat og work, then mechanical energy is conserved. But if there are forces exerted that is doing work on the system, then mechanical energy is not more conserved. Mootong kadtong ikaduha na dahil
Dili na
equation
ma'am.
ang atong gamiton. In this case, Elmarie, from the initial position, ato maning gibira. Okay, at rest siya initially. Gibira, so na I force exerted by the hand, right? The force exerted by the hand directing rightwards. It is also displacing rightwards. Now, is the hand doing work on the block while pulling it, while stretching it? Nagbuhat ba og work ang...
Yes, ma'am.
Yes. So there must be a force exerted by the hand as you are exerting this, I mean, stretching this spring through the block by pulling the block rightwards. So therefore, si spring karon, asa man padulong si spring? Si spring kay gi-stretch man ni siya padulong didto, opposing man gid siya no, or padulong kung mubalik man gid siya at x equivalent to 0. So your F spring will be directing leftwards. This is your
Right.
F spring. So aside from the spring or the elastic force, naapagid kay force exerted by your hand that is doing work. Again, from the initial position to your final position, is mechanical energy conserved or not?
Dili ma'am.
Dili na. Very good. Kay dili raman si elastic force ang nagbuhat og work, na amang kay work done by that other force. So mo na ni si work other. Okay. And we will be using katong equation katong ikaduha. We have K1 or K initial plus U grav initial plus ang elastic potential energy initial. This is equivalent to, okay, ay lang, apatay work other. Plus work done by that force. Work done by the other force. May go. So this is equal to, let me erase this ha. May gamay kay atong board. This is equal to, okay, the final values. Final kinetic plus final gravitational plus final elastic. Okay, the next step, we already have identified the equation that we can use. The next step is to cancel out those terms para masimplify ang ato ang solution. Naabatay initial kinetic energy. Ang pangutana diri
Wala
sa
ma'am.
initial speed. This is initially from
Wala,
rest. Okay, so ang imuhang initial speed
wala
is
ma'am.
0. Your kinetic energy will be 0. Next, do we have gravitational potential energy?
Wala gapon.
Okay. Sa imuhang initial, ako na lang na-erase lang, no? Imong initial og final position, the same ra man to gaina dire, no? The same ra og position. So we can cancel this out. Wala man siya nag-change og position along Y. So we can cancel out the gravitational potential energies. Next, do we have the initial elastic potential energy? Ang
Wala
aton,
gapon ma'am kay zero man ang katong
okay.
initial
So
position
initial,
ma'am kay zero man so wala.
okay, initial x nimo kay at 0. Your initial
Zero.
speed
Wala.
also is 0, right? So we can cancel this out. Okay.
Ma'am,
Naman tayo work
Masenso.
other. Naman tayo work other, no? Work done by the hand. Next, we are asked to find the final velocity, I think, right? Block's velocity, yes. We are asked to find the final velocity. I can't pause. Okay, so we will continue. So here we will have work done by the force, work other. So that will be the force exerted by the hand times the distance, and then cosine theta. Theta here is 0 degree because the force exerted and the displacement are the same direction. Take note, cosine 0 is positive 1. So this is equivalent to final kinetic energy is 1 half m v final squared plus, okay, your final elastic potential energy, we have 1 half k, what na sa'yo, 1 half mv squared, 1 half kx squared, 1 half k x final squared. Our target here is to find the final velocity, okay, so this term. So we will have to transpose this term on the other side, and we will get f times d, and then we have minus 1 half k x final squared. Okay, again we transpose this on the other side to the other side of the equation. So this is equal to, we have 1 half m v final squared. Our target again is the final velocity, so we have to divide both sides by 1 half m. Again, 1 half m. So we can cancel out 1 half as well as the mass here. Okay. Okay, let me transfer it here. And we will have, okay, the V final squared, this is equal to, kanina lang dayon. So we have FD, and then minus 1 half kx final squared all over 1 half m. Okay, since this is in square, so to find the final velocity, we will take the root, the square root. So what we have, plus minus square root of this value. Okay, next, we will substitute the values. The final velocity will be plus minus, we have the square root of, okay, the force is 0.61, 0.61 Newton. And then the distance is, it has moved 0.1 meter. 0.1 meter. Okay, minus 1 half. Your K again, your K. Suppose this block rest with a spring and stretch. You then apply constant force. Okay, you have the same K here in the previous example where your K is 5 Newton per meter. Okay, so we have 5 Newton per meter. And then your final X is 0.1 meter squared. All over 1 half times the mass. Katugyapon nga mass. sa previous example, a block with mass 0.2 kilogram. So that's 0.2 kilogram. Okay, so punching it in the calculator, we will get 1/2 5 0.1 squared divided by 1/2 and 0.2. Take the square root. Okay, if I'm not mistaken, that is 0.6. So the final velocity is plus minus 0.6 meter per second. Okay. Now, balik ta, kung asa man aning duha, it is either positive or negative 0.6 meter per second. Take note, it is being stretched rightwards, directing to the positive direction. So, therefore, ang atong ihatag nga value for the final speed is the positive value 0.6 meter per second. Okay? That's it. Thank you for listening.